Welcome to qnawire.
Is about analyzing the data obtained from experiments, and the experiment involves capacitors and the energy stored in the capacitor. So, the capacitor has an initial separation, the plate separation of 0.05 cm, and then connected to a 24 volts battery. There are two experiments. So while the battery is connected, you increase the plate separation, then you measure the energy stored in the capacitor. The second experiment, when after the capacitor is fully charged, you disconnect the battery and you increase the plate separation and you measure the energy stored. Okay. So then we have this graph of U versus 1 over D, and we get a positive gradient. Okay. So there are three parts in the question. We want to find out which experiment corresponds to the graph, or which, to the graph that is being shown. Okay, and then calculate the area of the plate and determine in which case the energy of the capacitor increases. Okay, in both of the experiment. Okay, so part A. Okay, so to decide which experiment corresponds to this graph, first we look at the what we observe from the graph. Okay, so as 1 over D increases, okay, U increases. Okay, so you can also say that as 1 over D increases, D decreases, U increases. Okay, then for experiment 1, okay, so what happens in experiment 1 is that the battery is still connected. So, and also we know the energy for the capacitor is half before that. Okay, there are three formulas for calculating the energy stored in capacitor. Okay, you can use half CV square. You can also use half Q square over C or half QV. Okay, depending on which of the, so in each formula, you have 2 out of the 3 quantities, Q, C, and V, involved in the formula. So you can use either one of the formula depending on which one is constant to compare changes in U. Okay, so now also one thing we need to note that in both experiment, we increases the plate separation of the parallel plate capacitor. So for parallel plate capacitor, AC is equal to epsilon naught A over D. Okay, so as D increases, C decreases. Okay, or you can think of it as 1 over D increases, C increases. Okay, so it really depends on how you see it. All right. Okay, so in experiment 1, we have battery remains connected. Okay, this tells us that the voltage is constant. So so if you use U equals to from U equals to half CV square, okay, as 1 over D increases. Okay, C increases, U increases. Okay, this is what the graph is actually showing. Okay, and if you look at experiment 2, okay, battery is disconnected after fully charged. So this means that Q is constant. Okay, so we'll be using the formula U equals to half Q squared over C. Okay, and then as 1 over D increases, C increases. Okay, U decreases. Okay, so in a sense, yeah, because we are dealing with 1 over D over here, it's opposite of increasing D. Okay, so yeah, just take notes. So based on the data, based on the graph, okay, 1 over D increases, U increases. Okay, this matches the result, or this matches the output of experiment 1. Okay, okay, where the battery is connected. Okay, okay, so this is the answer for part A. Okay, so part B and C. Okay, for part B, we need to calculate the area of the plate. Okay, so first we calculate the gradient. So be using U equals to half CV squared, and we put the formula for C, epsilon A over D times V squared, and this is equal to M times 1 over D. Okay, so M is the gradient of the graph. Okay, and also this is equal to half epsilon naught A V squared. Okay, so we calculate the gradient of the graph. Okay, so I'm using the 2 points on 75 minus 20 times 10 to the negative 9 joules divided by 15 per cm. Okay, so if you do this calculation, okay, you get 3.67 times 10 to the negative 9 joule cm, which is 3.67 times 10 to the negative 11 joule meters, okay, in SI units. Okay, so half epsilon naught A V squared equals to 3.67 times 10 to the negative 11, and A is 2 times 3.67 times 10 to the negative 11 divided by epsilon naught 8.85 times 10 to the negative 12, and V squared, so 24 squared. Okay, so you calculate this, Okay. Okay, so you get 0.0144 meters square, and this is 144 cm square. Okay, so this is the area of the plate. Then in part C, okay, in part C, this is what we are supposed to answer. Okay, we need to determine in which case more energy will be stored in the capacitor when D is increased from 0.05 cm to 0.4 cm. Okay, so as D increases from 0.05 cm to 0.4 cm, okay, 1 over D decreases from 20 per cm to 2.5 per cm. Okay, we want the energy stored to increase, so for energy stored to increase, okay, the battery needs to be disconnected. Okay, we also explained this in part A. Okay, so we look at each experiment. We also look at how U would change in each case. So when you increase D to have increase in U, so as D increase, C will decrease, and if the battery is disconnected, then the U will increase with D. Okay, and also this also makes sense because there's electric field, they are pulling the plates together, although they are held in place, but because if one plate is positively charged, the other plate is negatively charged, they are actually attracting each other, and if you are pulling them apart, you are actually doing work against the electrostatic force. So you are increasing the electrostatic energy that is stored inside the capacitor. Okay, which is why in this case the battery, in the case when the battery is disconnected, and when you increase D, increasing the plate separation, you get more energy stored. Okay, and that's all for this question.